So this is going to be 27. 1 over 3 times that would be negative 9. Yes? X cubed. Am I right?
Yes.
Is this what we're supposed to get?
Yeah.
That's the answer?
Yeah.
So yes,
No,
we are.
it's just over 2.
Over 2?
Cubed over 2.
There's an over 2 somewhere?
Right.
Those of you that have done it, please, let's see what we missed out.
Oh wait.
Oh, there's an over 2. So what did we miss?
Oh, for the first one, the it should.
Yeah?
No.
Yeah?
Yeah.
Okay.
You should have put an extra 9 over 2 x cubed.
There's an x cubed here?
Yeah.
Where?
Oh, yeah.
When you expanded the e 3.
For here?
Yeah. Yeah.
Oh, yeah, because we need up to cube term. Hello? We need up to cube term. So yes, I should have included that. Sorry about that. So this is going to be 3x, yes, cube over 3 factorial, right?
Yes.
So that would have been, this is 27, this is 6. So we're going to have something like 27x cubed over 6. So we can divide by 3. 9x cubed over 2, yes. So that's a missing term here. This still doesn't, is not affected, right?
Yeah. It's fine.
Okay. So we have,
No, I think it's fine, Mr. Downey. Just put it again at the
I can
end.
put it
I
here.
think it'll make sense.
no, I don't want, because if someone is checking this later, I don't want them to get confused. You might get it, but someone checking later who is not here may find it difficult to connect. All right? So what did I erase now is
No, wait, minus 1.
Minus
Yes.
1 over 3.
outside the bracket?
Yeah.
Yes.
Okay. Karen and Clarissa, I can't hear your voice, so I don't know if I'm making sense. Something like that. So that is going to be included here also. It's okay, it's okay, it's okay, it's okay. So we have 9x cubed over 2, then minus 1 over 3. So we only have 3x cubed plus the rest. Right? So now we're good. So 9x cubed over 2 minus 9x cubed. And a whole bunch of stuff, right? So this is 18 over 2. So we get negative 9. And that's what we are trying to find, yes. 3x. Of course, this is not a given problem. I'm only referring to that because you have done it. So I'm trying to work towards what we expect to get. Okay? That's what you're supposed to get. The next question is limits. The last question says, answer otherwise, find the limits as x tends to 0, f of x minus 1 divided by arctan exponential 3x minus 1. So basically, you have your f of x minus, what is our f of x? Do we have exponential lower series of f of x? That's it.
Yes.
So if you substitute that, we get 1 plus x squared over 2 factorial and so on, then minus 1. Then arctan of this we just finished. We get 3x plus 9 over 2x squared minus 9 over 3 over 2x cubed. Continues. Limit, please. Hello? Got it? So that gives definitely limit again. X tends to 0. Here we are only left with x squared over 2 factorial and so on. And this is going to be the same. So you can see that x can be factorized, right? If we factorize our x, I'm going to skip that. Please do not skip. I'm getting, if I factorize x and cancel x from both, understand?
Yep.
Factorize x, we're having 1 here, we're having x here. And on the bottom we have 3. We have 9 over 2x, 9 over 2x squared. Okay? So then we can substitute 0. Otherwise, you're going to end up getting 0 is over 0. You don't want indeterminate form when it is not indeterminate form. So, if you substitute 0, all the term in x will become 0. And so we get 1 over 3. And that's what we're supposed to do. Let's look at how the grading is allocated. We have talked about the expansion one. Okay, now for this one, you can see clearly substituting x into the Maclaurin series of that. Wait, did I do this? Oh,
Yeah.
this is method 2. Oh, okay. You don't have to use this method. So you can actually use exponential sine x. You have this, right? And you have an expansion for sine already, so you can substitute it, but that would be so many expansion. Then you realize the coefficient is going to be this factorial divided by whatever you get from here, so I wouldn't recommend that. It's quite long. But of course, if it's convenient for you. Then C part, we have, exactly 1, sorry. For C part, substituting 3x, which is this one. You see, there's a mark allocated for this. And for getting the final result, there's a mark allocated for that. Substituting exponential 3x minus 1 into the arctan, which is this one, you get some marks for it. And for getting something complicated, you get that. For selecting the appropriate term, which is something we did here. So here alone, you get your A1. For selecting the terms, appropriate terms, you get another M1 here, before you get to the last part where you get the last point. Understand? And for here, for substituting the series, they use their series in case you made a mistake in the previous one. Okay? So you can still get a follow through because the method is okay. So you get your M1 for that, for substituting the appropriate series that you got before. But in the same whereby your series previously is wrong, but you're putting the right series, we are going to be confused because that's not your series. It says their series, but that's not your series. Understand? So you get 1 for that, and doing necessary things, and getting the final result, you get the last 3 points. Please take note of all this. Okay. Another method is L'Hopital's rule, which appears in your investigation paper 3. But some of you could not figure it out that L'Hopital's rule. So you can use L'Hopital's rule by just differentiating and substituting. But I think the substitution of the series is easier. Okay? So this is where we stop for today. When we see on Thursday, we will review, I think, maybe we'll review paper 3 because it's short. Because on Friday I wanted to do paper 2. Or maybe I review paper 2 first. What do you guys think? Review paper 2 first? Paper 2 first? Okay. But we may not be able to cover everything. And I want to still give you a paper 2 on Friday because of the 90 minutes. Or I could make that on Monday. How about we just, up to Friday, we just go through with our correction. Then Monday we can take another one. So hopefully by then I will have graded the ones that you did. Alright? Thank you guys. See you.